Here we shall start a new chapter, that is Unit 3, called Calculus. Mean value theorems. We have three mean value theorems as Rolle's theorem, Lagrange's mean value theorem, and Cauchy's mean value theorem. First we will discuss about Rolle's theorem. Let f of x be a function and in the interval a comma b such that f of x is continuous in interval a comma b and f of x is differentiable in open interval a comma b. And third condition, f of a should be equal to f of b. The first condition is the function which is given f of x, that should be continuous in a given interval, and here interval will also be given. So in that interval the function should be continuous. It means there should be no breaks. And then second condition you need to have is the function should be differentiable in open interval a comma b. The derivative of that should not be equal to infinity for all x belongs to the given elements a comma b. And the next third condition you need to have is f of a should be equal to f of b. So the interval will be given as a comma b, and what the first value should be substituted in the given function, that is f of a. It means in the place of x you need to substitute a, and that f of a should be equal to f of b. If those are equal, then this condition will be satisfied. Then after we can proceed further. After this, there exists at least one point c that belongs to a comma b. After satisfying these three conditions, there exists one point c, and that point c lies between a comma b. So such that derivative of c, that is f dash of c, will be equal to 0, and we have to solve it further. We'll see the geometrical interpretation of Rolle's theorem. The curve y is equals to f of x, and the first is it is continuous in a given interval a comma b, that is a function f of x. And the next, at every point x is equals to c, where a is less than c less than b, it means c is lying in between the interval a and b, at the point c of f of c. So the point is c comma f of c. On the curve y is equals to f of x, there is a unique tangent to the curve. So when we draw the curve of the function f of x, at the highest maximum point you will get a tangent, and that is tangent to the curve, and that will be parallel to the x-axis. The point is called as c comma f of c. And then f of a will be equal to f of a will be equal to f of b, that is a third condition. That is, the two endpoints of the curve y is equals to f of x corresponding to x is equals to a and x is equals to b have the same ordinate, that is y coordinate. That is, they are at the same height with reference to the x-axis. Under these assumptions, there is at least one point on the curve where the tangent is parallel to the x-axis. So the third condition is f of a will be equal to f of a will be equal to f of b, and these are the two endpoints of this curve. And at least there exists one point where the tangent is parallel to the x-axis. If you see the graphs here, the first graph, it's a continuous graph. It means there is no breaks at all, and it is differentiable. And the next, f of a will be equal to f of a will be equal to f of b. And then here, if we take 2 points a and b, let this point be a comma f of a, and b is b comma f of b. So the first point is a, and when we plot it on the x-axis, this will be the point a, and for the b, this will be the point b. So this is a curve, and this curve is y is equals to f of x. So this is a y-axis and this is a x-axis. And the next, here at highest point, if we draw a tangent here, and this tangent is parallel to x-axis, and this point is c. See, if we draw if we drag it to the x-axis, this will be the c, and the point comes as c comma f of c. So the statement tells that there exists a point, that is c comma f of c, and when we draw a tangent, that will be parallel to x-axis. If you see the second graph here, the second graph is like this, and it's a continuous graph. it means there is no breaks at all. And this, let it be as a point A, that is a comma f of A, and let this be as point B, that is b of b comma f of B, and this will be the A and this will be the B. So if we see the point here, maximum point, this point will be the C comma f of C, and this will be the tangent. So, and here the note points we have: every polynomial is continuous and differentiable. uh, the polynomial functions like x square, x cube, or x power 4. So only positive powers are continuous and differentiable, not the negative terms. Negative terms like x power minus 1, that means 1 by x, and or y power minus 2, that equals to 1 by y square. So the negative powers of the variables are not continuous and differentiable. We have to check the given interval also. But for the positive powers like x square, x cube, and x power 4 and so on, for all these positive powers polynomials, every polynomial is continuous and differentiable only for positive powers. And the next second point is sin x, cos x, e power x, e power minus x are continuous everywhere. So these are always continuous. And coming to tan x, we have tan x, and this tan x is continuous only in between 0 to pi by 2. If the interval is given as 0 to pi, it is discontinuous, because the graph at tan is equals tan pi by 2, at tan pi by 2 you will get infinity. It means it is not defined, you will get a break there. So by the interval we can say whether it is continuous or not. If it is given from 0 to pi by 2, we can say it is continuous. But if they ask 0 to pi, we say it is a discontinuous function, because at tan is equals to pi by 2, it tends to infinity. We shall solve few problems based on Rolle's theorem. So verify Rolle's theorem for the function f of x is equals to 2x cube plus x square minus 4x minus 2 in the interval closed, that is minus root 2 comma root 2. And we know that Rolle's theorem, it satisfies three conditions. First one is continuous function, and second one we'll check whether it's differentiable or not, and third condition, f of a will be equal to f of b. And the next, we like the function f of x is equals to 2x cube plus x square minus 4x minus 2. It is a polynomial function. The degree, it's a polynomial, it's a cubic polynomial. So we know that it is a continuous function since every polynomial is continuous. We write this statement also, that is every polynomial is continuous. So therefore f of x is continuous in the given interval minus root 2 comma root 2, that is a closed interval. And the next, we will check whether it's differentiable or not. So f dash of x is equals to, we have to differentiate this function, f of x. So derivative of the function 2x cube plus x square minus 4x minus 2 will be as 2x cube differentiation is 3 of 2x square plus x square differentiation with respect to x is 2x minus 4x differentiation with respect to x is minus 4, and constant differentiation is 0. So we have f dash of x is equals to 6x square plus 2x minus 4, and f dash of x is exist because it has a finite value. So whatever the values you give for x in between minus root 2 and root 2, you will never get infinite value, you will get a finite value. So f dash of x is exist in the given interval minus root 2 comma root 2. So we have to write only open interval minus root 2 comma root 2 for the differentiation. For continuous you need to write closed interval. So for any value in between these two, in between the given interval, we will never get a infinite value. So we will always get a finite value. Therefore f dash of x is, therefore we write a statement as f of x is differentiable in open interval minus root 2 comma root 2. The second condition is also satisfied. So furtherly we go for third condition, that is f of a is equals to f of b. So f of a is equals to f of b. Here the interval is closed interval minus root 2 comma root 2. When we compare it with a comma b, a is minus root 2 and b is root 2. So in the place of a, you need to substitute minus root 2 and root 2. So that is f of minus root 2 should be equal to f of root 2. So first we will substitute minus root 2 in the given function, that is f of x. So f of x is 2x cube plus x square minus 4x minus 2. So in the place of x you need to substitute minus root 2 and you further calculate it. You will get it as 2 of minus root 2 whole cube plus minus root 2 whole square minus 4 of minus root 2 minus 2. And that equals to minus root 2 whole cube. It means minus root 2 into minus root 2 into minus root 2 into minus root 2. So minus root 2 into minus root 2 comes as root 2, 2, and then into minus root 2. So further you will get it as minus 2 root 2. So minus root 2 whole cube is minus 2 root 2, and root 2 minus root 2 whole square is 2, plus minus into minus becomes plus, and 4 into root 2 is 4 root 2 minus 2. So further you will get minus 4 root 2 plus 2 plus 4 root 2 minus 2, and plus 2 and minus 2 gets cancelled, and plus 4 root 2 and minus 4 root 2 also gets cancelled. So furtherly f of minus root 2 we got it as 0. So therefore f of minus root 2 is equals to 0. And next you need to check for f of root 2 whether that value is also equal to 0 or not. And then after we substitute root 2 in the function, that is f of root 2, that equals to 2 into root 2 whole cube plus root 2 whole square minus 4 into root 2 minus 2. This comes as 2 of root 2 whole cube is 2 root 2 plus root 2 square is 2 minus 4 root 2 and minus 2. So furtherly we will get 4 root 2 plus 2 minus 4 root 2 minus 2. So plus 2 minus 2 gets cancelled, and minus 4 root 2 plus 4 root 2 gets cancelled. So furtherly you got f of root 2 is value is 0. So f of minus root 2 is equals to f of root 2 is equals to 0. The first condition is satisfied, that is it is a continuous function, and then second condition it also satisfied, it's differentiable and we get a finite value. The third condition is also satisfied, that is f of a will be equal to f of b, that is f of minus root 2 is equals to f of root 2. So therefore we write a statement, three conditions of the Rolle's theorem are satisfied, and we have to solve it further, that is such that c belongs to minus root 2 comma root 2. It means there exists a point c and it lies somewhere in between minus root 2 and root 2. So c belongs to minus root 2 comma root 2. And then f dash of c will be equal to 0. This is a condition. F of c will be equal to 0. The derivative of the c function will be equal to 0. So f dash of c, that equals to, we got the f dash of x, that is 6x square plus 2x minus 4. But here in the place of x you need to substitute c. F dash of c is equals to 6c square plus 2c minus 4. And given that f dash of c will be equal to 0. So this differentiation will be equal to 0, and from this if we take 2 common, if we take 2 common we get 3c square plus c minus 2, and we send the 2 to the right hand side, it becomes 0. And then next it's a quadratic equation. We will solve the quadratic equation by splitting the middle term, 3c square, and c can be split as 3c minus 2c. And when you split it here, 3c minus 2c, again you will get back to c, then minus 2. So the multiplication of these two will be the multiplication of the first and last term, that is 3. So 3c into 2c, that is 6c square. So 3c square into 2 will be also 6c square. So this is a procedure for solving quadratic. So 3c square plus 3c minus 2c minus 2 is equals to 0. And from this we take 3c common from these two terms, we get 3c of c plus 1, and from this we take minus 2 common, so minus 2 of c plus 1. So minus 2 into c is minus 2c, and minus 2 into 1 is minus 2, and that equals to 0. So from this 3c minus 2 is one term, and c plus 1, from this both the common c plus 1, so c plus 1 is also another term, and that equals to 0. So these two terms are multiplying together and it is equals to 0. So finally this term is also equal to 0 and c plus 1 term is also equal to 0. So 3c minus 2 is equal to 0 and c plus 1 is equals to 0. So from this send minus 2 to the right hand side, you will get plus 2. So 3c is equals to 2, and here send this 1 to the right hand side, you will get minus 1. So c is equals to minus 1, and from this c is equals to 2 by 3. So the c value you got it as -1 and 2 by 3. So c is equals to -1 comma 2 by 3. These are the values of c where the tangent is parallel to the x-axis, and these 2 points are belongs to minus root 2 comma root 2. These 2 points lies in between minus root 2 and root 2. So therefore we write the statement as hence Rolle's theorem verified. Here we go with second problem, that is verify Rolle's theorem for f of x. The function is x square minus x minus 6 by x minus 1 in the interval minus 2 comma 3. So given f of x is equals to x square minus x minus 6 by x minus 1 in the interval minus 2 comma 3. So we had to check here whether it's continuous or not. First, f of x is equals to the function x square minus x minus 6 by x minus 1. This is equal to infinity at x is equals to 1. So in the interval minus 2, 3, there exists an integer 1 also, and when we substitute this 1 in the place of x, so that is f of 1 is equal to 1 square minus 1 minus 6 by, in the denominator we have x, that is 1 minus 1, and that equals to, in denominator you will get it as 0. So when denominator is 0, you will get an infinite value, and x is equals to 1, that belongs to minus 2 comma 3. The interval is given minus 2 comma 3. So the in between minus 2 and 3 we have the integers like minus 1, 0, 1 and 2. So at minus 1, when you substitute in the denominator, here when you substitute here x in the place of x, when you substitute minus 1, so minus 1 you will get it as minus 2. So there is no chance of getting an infinite value. Similarly, you need to check for another integers which are present in between minus 2 and 3. So next we have 0. So when you substitute 0 here, 0 minus 1 becomes minus 1. So here also you don't have getting an infinite value. And the next you have 1. So when you substitute 1 in the place of x, 1 minus 1 becomes 0, and at this point 1 you will get an infinite value. So and that value that is 1, which is belongs to the interval minus 2 comma 3. So therefore we are writing as f of x is not continuous at x is equals to 1, and that 1 belongs to the interval minus 2 comma 3. So the given interval, and at 1 it is having an infinite value, it is discontinuous at this value, and that value is present in the given interval minus 2 comma 3. So therefore we write a note point, that is Rolle's theorem is not applicable for the given function because it is not continuous. And the next, verify whether Rolle's theorem can be applied to the following functions in the given interval. So the first function is f of x that equals to tan x in the interval 0 to pi. So the given the function is tan x and the given interval is 0 to pi. So f of x is equals to tan x, and this equals to infinity at x is equals to pi by 2. So when you substitute x is equals to pi by 2 in the given function, that is f of pi by 2 is equals to tan pi by 2. Tan pi by 2 value we know it as infinity. So when you don't know the tan pi by 2 value, but we can write it as tan can also be written as sin x by cos x. So sin x nothing but when you substitute pi by 2, sin pi by 2 by cos pi by 2. So sin pi by 2 value is 1 and cos pi by 2 value is 0. So 1 by 0 is infinity. This will be the tan x. So in this way also we can do. But if you know directly tan pi by 2 value is infinity, that's okay. So f of pi by 2 is equals to tan pi by 2, and that value is infinity, and x is equals to pi by 2 belongs to 0 to pi by 2. So in between 0 to pi we have the value pi by 2. It means when you are taking the interval of 0 to pi, the pi by 2 also includes. So but that pi by 2, at this pi by 2 the tan attains infinite value. So we write a conclusion point, that is therefore f of x is not continuous at x is equals to pi by 2, and this pi by 2 belongs to 0 comma pi interval. So therefore we write a statement as Rolle's theorem is not applicable. Given function is discontinuous at the point x is equals to pi by 2. And then the question, we have f of x is equals to 1 by x square in the interval -1, 1. So f of x is equals to 1 by x square. This is equals to infinity at x is equals to 0. So at x is equals to 0, the function is discontinuous. It means you are getting an infinite value. So when you substitute 0 in the given function, that is f of 0 is equals to 1 by 0. 1 by 0 value is infinity. So, and x is equals to 0, that 0 belongs to the interval -1, 1. So when you plot it on a graph, you get -1 and 1. In between you have as integer, that is 0. So when you are taking the interval, the in between integers also applicable for the function. So when you substitute 0 in the given function, it attains infinity or it is discontinuous. So therefore f of x is not continuous at x is equals to 0, and that 0 is belongs to the interval -1, 1. Therefore Rolle's theorem is not applicable. Or you can, if they give the point like 2, 3, then f1 by x square is continuous, because 2, 3, in between the 2, 3 there is no 0, and whatever the values you substitute in between 2 and 3, you never get an infinite value other than 0. But they given the interval as -2, 1, so the value 0 includes, then 1 by 0 is equals to infinity. The function attains discontinuous. Therefore whereas f of x is not continuous at x is equals to 0, and it belongs to -1, 1 interval. Therefore Rolle's theorem is not applicable. So in this way we solve the Rolle's theorem. Thank you.